Thank you for joining our, again, first OGS online workshop. I really appreciate your participation and time. I'm also honored to present an overview of Oklahoma Shale Resources Play to you. I think it is important to recognize what we already know and what we do not know about the shale resources plays in Oklahoma, especially for those who are not familiar with this play in Oklahoma. Oops. Okay, so let's go ahead and get started. I would like to start with a bigger picture about the shale resources in the United States. And then I will discuss briefly what are the key elements for a successful exploration in shale resources plays. And I will also present briefly the source rock in Oklahoma, and finally briefly go through the shale resource plays in Oklahoma from oldest to the youngest, including the Sylvan, Arkansas Novaculite, Woodford, Caney, Goddard, Atoka, and last, the Pennsylvanian Shales. So this map is from U.S. Energy Information Administration, shows the major shale resource plays in the United States. We have Marcellus in the east, Haynesville and Eagle Ford in the Gulf Coast, Barnett in the southwest, Monterey in the Pacific, close to the Pacific Ocean, and Bakken in the Great Plain, Northern Great Plain, Niobrara in the Rocky Mountain area, and Woodford and Fayetteville in the Mid-Continent. So these are where the shale play works. And in total, these shale plays have unproved technically recoverable gas of about 622 TCF and oil of 78 billion barrels. So why are shale resources important? If we look at this US crude oil production graph, especially since 1973, when we started to record monthly crude oil production, the US oil production was actually decreased in a significant rate until the shale revolution in 2011. The technology, really, the hydraulic fracking and horizontal drilling, has opened up new area for the oil and gas development in shale reservoir. It turns what we as a geologist once thought as not attractive shale rocks into another America's oil booms. Same with the U.S. gas production. Since 2000, U.S. gas production has increased by 17-fold. And most of this production is attributed to shale gas since 2011, again, after the shale revolution. And in 2019, 75% of the U.S. gas production is from shale gas production. This data shows how important shale resource plays for U.S. energy and economy. So there are some things we know that makes a successful shale resource play. If we want to have a good productivity in shale resource play, we know we need to have a thick enough rock that has significant organic reach, or what we refer as total organic carbon. So we need to have thick shale with a lot of carbon, but not only carbon, but also hydrogen that have undergone right thermal maturity to generate a lot of oil and gas in place. Then we also need right kind of mineralogy in the rocks, which control the brittleness of the rock. Then when we fracture this rock, it will crack and allow the hydrocarbon flow to the wellbore. Having increase or high pore pressure and good ability to flow the hydrocarbon to the wellbore in terms of the permeability also help increase the productivity in the shale resource play. Now let's shift to the Oklahoma. If we talk about shale resource plays, we actually talk about shale source rocks. This table on the left shows a total of 385 oil samples collected from 81 fields in the Ardmore and Marietta basins by WAVREC to investigate the oil types and where did the oil source from. So these 365 samples represents complete stratigraphic column from Cambrian to Cretaceous period. And the result suggested that there are 7 types of oil in these 2 basins. Type A through E oil appears to correlate to Pennsylvanian, Mississippian, Devonian, and Mississippian, Upper Devonian, and Middle Devonian age source rock, respectively. Similarly, this histogram graph on the left with TOC in the x-axis and number of samples in the y-axis shows source rocks potential of 190 samples from Ordovician to late Pennsylvanian age shales in the Oklahoma and Kansas state. As we can see here, the Woodford Shale here and many of Pennsylvanian and Mississippian shales consistently have TOC greater than 2%, while the Ordovician rocks generally have low TOC, which is less than 1%, with some of the samples from Kansas state have TOC value ranging from 2% to 9%. And the Van Craven diagram on the right indicates the type of the organic matter of those 190 rock samples. A small number of Ordovician samples has higher hydrogen index value suggesting type 1 kerogen, and most of the Woodford and Pennsylvanian shales are plotted near type 2 and 3 curve. So another source rock studies focusing on the Anadarko Basin was conducted by Wang and Philp in 1997. This map shows the location of collected crude oil and source rock samples from Viola, Sylvan, Lower Mississippian Lime, Springer, Chester, and Morrow. And the kerogen typing plots on the right based on hydrogen index at the y-axis and the Tmax at the x-axis shows that the Viola limestone and the Woodford shale kerogen are mainly type 2 and the other group or formations are mostly type 3 kerogens. So we at Oklahoma Geological Survey actually Brian Cardot maintained a database of all Oklahoma shale and shale gas and shale oil wells completion, and he compiled it from the Oklahoma Corporation Commission Form 1002A. As of October 2020, as of December 2019, there are about 5,907 shale gas and shale oil wells completion, from the oldest Sylvan shales to the youngest Pennsylvanian, to the youngest Pennsylvanian shales. And most of them are drilled all over the Anadarko basins, Arkoma basin, Ardmore basin, and Cherokee platforms. So now I'm going to provide a brief summary of the primary shale resource play of Oklahoma. I'll start with the oldest Sylvan shale. The Sylvan shale is the Ordovician in age and contain type 2 and 3 kerogen. It generally has low TOC content, less than 1%, and based on Wang and Philp, the source rock potential for the Sylvan shale is poor in the Anadarko basin. This Isopach map shows the Sylvan shale distribution and thickness in meter. As we can see here, the Sylvan shale has a good lateral extension from West Oklahoma to West Arkansas, and it is thickening to the Anadarko basin. So despite of its poor source rock potential, as of December 2019, there are about 16 Sylvan and Woodford Shale in the huge Pittsburgh and Payne counties, and one wells in the Alfalfa County and another well in the Wood County. These two Sylvan's well in this North Oklahoma were actually drilled outside the Sylvan Shale Isopach thickness. If you see, it's drilled in a location where the Sylvan Shale is very thin or even absent. But the operator who drilled this report a production from Sylvan dolomite or Makukita, and the cumulative gas production from this well in Woodford County has reached tens of millions cubic feet since the completion in 2010. So this is how the Sylvan Shale looks like in the surface. This outcrop is actually close to the Arbuckle Mountain Fried Pies shop, and it is a clay-rich shale, and obviously it's a poor gas shale, but it is a very good fracture barrier. So now I'm going to talk about the Arkansas Novaculite. Arkansas Novaculite is a middle Silurian to middle Mississippian in age. It crops out in the Wichita Mountains fault thrust belt in Arkansas and Oklahoma. And the Arkansas Novaculite contains type 2 and type 3 kerogen with TOC value range from less than 1% to up to 12.5%. A sample from Bigfork quarry in the eastern Oklahoma shows that the Arkansas Novaculite has maturity less than 0.62% VRO, while samples from a well in the West Arkansas indicate VRO of 3.32% VRO. And as of December 2019, there are only 3 Arkansas Novaculite wells in the Wichita Mountain area producing gas. This is a photograph of Arkansas Novaculite outcrop in the Scratch Hill. As we can see here on the inset picture, it is highly fractured and could be a productive reservoir in the subsurface. So now the famous Woodford Shale. The Woodford is considered to be one of the most important hydrocarbon source rock in the Anadarko Basin and other regions of Oklahoma. It is late Devonian to early Mississippian in age, and the Woodford Shale contains predominantly type 2 and type 3 kerogen. The TOC content of the Woodford Shale range from less than 1% to up to 28%, with maturity range from less than 1% to 6.5% VRO. And this is Isopach map of the Woodford Shale. The color indicate areas where the Woodford Shale are present, and this white area indicates the area where the Woodford Shale is absent. As we can see here, the Woodford Shale is laterally continuous, covering almost all of the state of Oklahoma, and it is thickening to the south toward the Anadarko Basin and the Ardmore Basin. Since 2004, well completion to the Woodford Shale have expanded from initially in the Arkoma Basins only to Anadarko Basins, Ardmore Basins, and also Cherokee Platform. It's also expanded from primarily gas production to gas, condensate, and oil production. And this map shows as of December 2019, there are 5,445 Woodford Shale well completions, and it is plotted by well types on this geologic province map of Oklahoma. So based on the geologic province map, there are 4 Woodford Shale plays in Oklahoma. The first one is in the Arkoma Basins. This western Arkoma Basin in the eastern Oklahoma has produced gas at thermal maturity from around, as you can see this black dot area, around 1% to 3% VRO. And the oil or condensate production is come from the area with the thermal maturity up to about 1.67% VRO. The second one is in the Anadarko Basins. The Woodford Shale produce gas at the thermal maturity from less than 1% to about 1.6% VRO, and produce oil or condensate at thermal maturity up to 1.5% VRO. The third one is in the northern central Oklahoma, including the Cherokee Platform and the Anadarko Shelf. The Woodford Shale in this area produce oil and gas at thermal maturity less than 1% VRO. And the last one, or the fourth one, is the Ardmore and Marietta Basins, where the Woodford Shale produce oil condensate and gas at thermal maturity less than 1.8% VRO. So the Caney Shale. So Caney Shale is the first shale resource play in Oklahoma. It is age equivalent to Barnett Shale in Texas and Fayetteville Shales of Arkansas. The Caney Shales contain type 2 and type 3 kerogen with less than 1% to about 11.46% TOC. And analysis of Caney core samples from Garfield and Marshall counties as annotated by these number 1 and number 2 wells suggested that the Caney Shale has maturity value range from 0.55 to 1.14% VRO. And this total Mississippian Isopach math by Chert 2016 shows that we have a pretty thick Mississippian deposits, and he also studies the Caney shales in the Arkoma basins as shows in this map. And it shows that the Caney shales thicken to the western of the Arkoma basins. And as you can see here, the two green stars, it's annotated as the Barnett Shales extension to Oklahoma. And there are 2 wells drilled into this area, I mean specifically to the Barnett Shales producing oil and gas. And as of this, excuse me, as of December 2019, there are 131 Caney Shales well completions, and early well completions in 2001 to 2010 to relatively ductile clay-rich Caney Shale in these Arkoma basins has a relatively poor gas production. And while drilling from 2012 to present in Caney Shales in the Ardmore Basin has a better oil and gas production. So the next one is the Mississippian H. Goddard Shale, and it is the newest shale resource place in Oklahoma. It contains type 2 and 3 kerogen with less than 1% to 7.77% TOC, and the thermal maturity range from 0.6% to 1.26% VRO. As of December 2019, there are 166 Goddard Shales well completion in this Carter, Garfield, Grady, and Stephens County. So the Atoka Shale, it is a Pennsylvanian shales. Most of the Atoka Shale studies were done in the Arkoma basins, and we know very little about the Atoka shales in the Anadarko basins. The Atoka shales contains type 2 and type 3 kerogen with 0.22 to 2.92% TOC, and the thermal maturity ranges from less than 2 to more than 3.6% VRO. And there are only 1 Atoka shale wells completion in this Ellis County, and IHS Energy News stated that this Pennsylvanian Atokan shale is an emerging unconventional gas resource play in the Anadarko basins, as well as in Texas Panhandle. And EOG obviously has completed 26 horizontal wells, and it produced about 7.7 cubic feet per day per well. And this play is attributed to about 400 billion cubic feet of Atoka recovery potential to its 60,000 net acres. Another Pennsylvanian shale is the Excelsior shales within the Cherokee group. As stated by Tedesco 2015, the Excelsior shale is a productive shale because it has over 50% quartz and carbonate minerals, making it more brittle, allowing hydraulic fractures stimulation to be effective. And the Excelsior shales contain type 2, type 3, and type 4 kerogen with less than 1% to 1.2%, 12% TOC, with thermal maturity value range from 0.45 to 0.76% VRO. And as of December 2019, there are only 2 Pennsylvanian shales wells completion. One was reported as Cherokee completion with no production, and the other one was perforated at Nuyaka shales, Mulkey coals, or the Excelsior shales, and Oakley shales, and this well is producing gas. So I would like to close this presentation by showing you the summary of major Oklahoma shales oil and gas well completions, including the Woodford, Caney, and Goddard shales from 2004 to 2019. And as we can see here, the number of well completion is actually closely tracking the oil price. So it's for me, it is strongly cyclical, and I am very optimistic that this will recover in a very short future. And the last one is the I would say that the oil shale are different and complex, and we need to do our homework in recognizing the uncertainty in this shale plays and properly characterizing them. Thank you.